Okay, go ahead and take a moment to complete your warm-up in the warm-up section of your notebook. Make sure that you show all of your work. Today we're going to be talking about transformations, and specifically reflections, translations, and dilations. Tomorrow we'll be talking about rotations. So a transformation is a change in its position, shape, or size. The original figure is the pre-image, and the resulting figure is the image. Isometric transformation is when you have a pre-image and your image that are congruent. That means they do not change size. Some important vocabulary that you need to know is that to transform, just like Transformers, y'all just saw a introduction of the movie or the show Transformers. To transform means to change a shape by turning, flipping, sliding, or resizing. And a rigid transformation, you have a pre-image and an image, and they both have exactly the same size and shape since the measures of the corresponding angles and corresponding line segments remain equal. They are congruent. Congruent means that the figures are the same size and the same shape. And then you notice that this is the congruent symbol that we will use in math. Translations, I've underlined the letters SL because that can help you remember. Translation means to slide a figure. A reflection, that FL is underlined, and that's a way that you can remember what reflection means. It's the flipping of an object over a line, and that line is known as the line of reflection. A reflection is a mirror image where the original figure, ABC, is flipped over the X or the Y axis or another line that's given to create a new image. And you'll always note the new image using this prime mark. It looks like an apostrophe, but we call those prime marks. To reflect an image, you're going to count the number of spots from the axis or the line of reflection. Then you're going to move that number of spots to the other side of the axis. So let's look at an example of that. So the first example says to reflect across the x-axis. So here's our x-axis. I've put a dotted line at the x-axis. We have our original figure GQL, and we are going to flip it over that line of reflection, which is the x-axis. So Q is on this side of the x-axis. So when we count the spots, it's only one spot away from the x-axis. So you're going to count one spot on the other side of the x-axis, and that will become Q prime. Then let's look at the G. The G is on this side of the x-axis, so I'm going to count the number of slots. It's 1, 2, 3, 4 units away from the x-axis. So if we reflect it, it's going to be 4 units on the other side. So 1, 2, 3, 4. And when you note that, it's G prime. And do not forget the prime marks. So L is on this side. When we reflect it, it's going to be on the other side of the x-axis and the same number of slots. Notice that the size of the shape did not change. The shape did not change, just the position of the shape changed. Number 2. Another example would be you see our original figure XLU, and then in red I have reflected this figure. So U is on, and we're reflecting across the line Y equals 3. So to the right over here I've put a couple of notes. Anytime that you have Y equals a number, you're going to have a 0 slope. That means a straight line across, because your mx, if you think about the equation of a line, y equals mx plus b, the only way that your mx can actually go away is if 0 is what your slope was, and 0 times x is going to make that x go away. So that means that your slope is 0, and a way that I often remember that is you can make a z with this line. That has a 0 slope, so it's going to cross the y-axis at positive 3, and it's going to have a 0 slope. An undefined slope, you can make a u with those lines, and it's always going to be when x equals a number. So like if x equaled 3, then you would have a line going vertically down your paper through the x-axis at positive 3. But in this case, we're looking at y equals 3. So when we reflect over that line, you have your original u, and when we reflect it, u prime is on the other side of that line, 2 units away from y equals 3. Then we have x, and it's 2 units away from the line y equals 3, so we're going to go 2 units on the other side, and you see that I have an x prime. Then the L is already on this side of the y equals 3 line, so when we reflect it, it's going to go to the opposite side. So it's 2 units away, so we're going to go to the other side, and it's going to be 2 units away, and we have L prime. Again, this is a rigid transformation because the size of the shape has not changed. So this is another example, the reflection of the x across the x-axis. And in this problem, it did not graph the original image. I had to go ahead and plot the ordered pairs. Then I plotted the image, and the image is in purple. The pre-image is in red. That was the original figure. Write a rule to describe each transformation. So sometimes you're going to be given a transformation, and remember, you can tell what the original figure is because it does not have the prime mark. So on the left over here, we have a figure, a triangle, KHI, and on the right hand side we can tell that this is the image because of those prime marks. So I can tell that it was reflected across the line x equals -2 because this is a vertical line that crosses the x-axis at -2. So you can write the rule for that. Another type of reflection is reflecting over the line y equals x. And both the x-coordinate and the y-coordinate are going to be switched whenever you flip across the line y equals x. And remember, just like we talked about, this is an equation in slope-intercept form, but in this case, the b value is 0 because the line y equals x does not have another y-intercept. So that line is going to look like what I've plotted over here. So we have the line y equals x plotted. And for each of these, 2, -4. So to reflect that, if we look at the point 2, -4, I have an A plotted here. So the reflection of that would be just flipping those around. -4, 2. So -1, 2, 3, 4, +2. And notice that it's been reflected across this line y equals x. You could plot each of these points, -4, 2. So -4, +2 is our original, our pre-image, and then our image is going to be just flipping that x and y axis, so, or x and y values, to -4. So over 2, down -4. With C, our original, our pre-image is -1, -3. And make sure that you always label your original. So we have a C, and then if we were to find the reflection of that, we're just going to switch our x and y values, -3, -1, reflects it, and make sure that we put the prime mark, showing that that is the image. And it's been reflected across. It's the same distance from that line. Reflect over the line y equals -x. So we've already talked about the reflection over the line y equals x just swaps the x and y coordinates. With the reflection over the line y equals -x, that's going to swap the x and y coordinates, and it's going to change the sign of each of those. So for example, if we have the point, let's say that we have the point 3, 4. So over 3, up 4. So let's say that we have this point. And the reflection of that is going to, we're going to switch those. If it's reflected over the line y equals x, you're just going to switch those. But if we are, so that would be, we would, if we were reflecting over the line y equals, let me just erase this, that's already there. Okay, so if we were reflecting that point, 3, 4, so the reflection of this point is going to be 4, 3. So over 4, up 3. And notice that it's been reflected across the line y equals x. Now the line y equals negative x is going to have a negative slope. So let's start from this side. And the slope is going to be down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So this would be the slope, or this would be the line of y equals negative x. So if we were reflecting across that line, then we have to do something a little bit different. You're going to swap the x and y coordinates and change the signs. So what this looks like is we would take the point 2, 5, so over 2, up 1, 2, 3, 4, 5. So that is our pre-image. And then when we reflect it across the line y equals negative x, we have negative 5. So we're just switching the x and y. So we're switching those values, and we're also changing the sign. So negative 5, 1, 2, 3, 4, 5, and negative 2, down 1, 2. So that would be our point. I'm sorry, my points are bad. Okay, so we have reflected it across this line. So those are two rules that you need to remember. If you are reflecting across the line y equals x, you're just going to swap the x and y coordinates. If you're reflecting across the line y equals negative x, you swap the x and y coordinates, but you also change the sign. And you would also do that if you had a figure that you were changing. Okay, to translate. Now, you don't need to write all of this stuff down, but if you're a steps person and you prefer to, go right ahead. But to translate just means to slide the figure. And again, a way that I remember that is translate has an SL in the word. So translate means to slide, and to translate a figure on the coordinate plane, you must slide the figure in the direction given in each problem. So you're going to choose one point on the original figure and slide it in the direction that's given. This new point will be labeled with a prime number. Remember, your new points are always labeled with a prime number after each new letter. So this symbol is called prime, which lets you know that this is the new image. Then you're going to slide the other points in the exact same direction as the first point, and every single one of them are going to be labeled with a prime mark. So then you'll always draw lines to connect to create your new image, which should be identical to the original, just in a new place on the coordinate grid. So it should not turn. The only thing that your figure should be doing is sliding. So if we look at an example of this, translate 1 unit to the left. So look at our original figure. It's in black here. GUQX. And then if it were translating it 1 unit to the left, every letter is just moving 1 unit to the left. So the G prime is here. X, our original, our pre-image is here, and then our image is 1 unit to the left. Here's our pre-image for Q, and our image is 1 unit to the left, and we mark it with a Q prime. U, our pre-image is here, we're moving it 1 unit to the left. And then make sure that you always connect your new figure and you put the prime marks. So here's another example of that, 1 unit to the right and 2 units down. So each point, the T, you're taking it 1 unit to the right, 2 units down. The E, 1 unit to the right, 2 units down. 1 unit to the right with the I, 2 units down. And each one is marked with a prime. Okay, sometimes you're going to be given the coordinates and then you're going to be given what to do. So translation, 2 units to the left and 1 unit down. So another way that you might see this written is x minus 2. And the reason for that, 2 units to the left. Remember, left and right is what's happening on the x-axis. Up and down is what's happening on the y-axis. So your y values are what moves your point up and down. Your x value is what moves it left and right. So if we were to plot these new points, I could go ahead and write my rule just based on this phrase, 2 units to the left. So I'm taking my x value and I'm subtracting 2. 1 unit down, I'm taking my y value and I'm subtracting 1. So I can go ahead and write my new ordered pairs. If my original ordered pair is 0, negative 1, I'm going to take that x value and subtract 2. So 0 minus 2 is negative 2. I'm going to take the y value and subtract 1. Negative 1 minus 1 is negative 2. Then with each point, negative 2 subtract 2 is negative 4. 2 minus 1 is, 2 minus 1 is 1. Then for the v, 2 minus 2 is 0. 4 minus 1 is 3. 3 for the j, 3 minus 2 is 1. 0 minus 1 is negative 1. So when we plot our new image, we can plot the pre-image. I'll go ahead and plot that 0, negative 1. And my writing's going to be bad because I don't have a pen. I'm doing this with my computer. So we have a Q, we have a D at negative 2, positive 2. So D. We have a V at 2, 4. And we have a J at 3, 0. So this is my pre-image, and I'm going to connect it with lines. So since I'm just sliding this figure, the shape of it should not change. So I'm going to do my image in a different color. So negative 2, negative 2, negative 4, positive 1. Oh, and this would be, and what we're doing is we're taking it 2 units to the left, 1 unit down. So we have this is Q prime. And make sure that you note that. This is going to be D prime. Then we have 0, 3, so 1, 2, 3. And that's V prime. And then we have J prime at 1, negative 1. And I'm going to connect that. Okay, so notice that the shape of my figure has not changed. That only I have just slid the figure to the left and down 1. Okay, so another way that this is written is in vector notation. So this is very important that you write vector notation. Okay, so here I have not described in words, but I have described in a different form what's happening. So remember, your x value always comes first, your y value always comes second. So this 2 is saying that the x values are going to move to the right 2. And the reason why I know that it's moving to the right 2 is because it's a positive 2. And the y values are going to be going up 5. So we could write this as x plus 2. All of the x values are increasing by 2. All of the y values are increasing by 5. And if you wanted to write that out in words, you could. The x values are increasing by 2. The y values, or the x values, are go to the right 2, and up 5 is a way that you could write it in words. Here, to the right 4, and up 1. Your x values are increasing by 4. Your y values are increasing by 1. Here you have a negative 3 first. So the x values are decreasing by 3. So you're going to the left 3 and up 8. And then here for number 4, you're going to the right 7 and down 2 because your x values are increasing by 7 and your y values are decreasing by 2, so you're going down. For number 5, the x values are decreasing by 1, so that means you're going to the left 1 on the x-axis, and then you're taking your point and you're moving down 6. So your y values are decreasing by 6. Okay, so you can also describe each translation using an ordered pair. So 0, 0 units to the right, 4 units up. And or you can write this in vector notation, and the way that you would write that is 0 and 4, because you're not moving anywhere right or left. And remember, the x-axis is from right to left, the y-axis is up and down. So 4 units up would be a positive 4. And notice that we use these symbols, and that is the vector notation. So let's look at numbers 10 through 15. In the diagram, find the image of f under the translation described by the figure, or by the given vector. So we have f here, and -1, 4. So that's saying the x values are going down 1, the y values are going up 4. In other words, we're going to the left 1, and we're going up 4. So 1, 2, 3, 4. C is the point that's at that location. For number 11, 4, -1. This is our x, and this is our y. Sorry, that looks bad. Okay, so the x values are increasing by 4, and I know that it's increasing because it's a positive 4. So I'm going to go back to my f, and my x values are increasing by 4. So I'm going to the right on the x-axis. Think about the x-axis, right and left. 1, 2, 3, 4. And I'm going down 1 because it's a -1. So 8 is at that point. Okay, so I would like for you to try, what is the image of Z under each translation? Okay, so these are the answers. So for number 1, X is the image because we go to the right 2, down 2. Number 2, U is the image because from Z we go to the right 5 and down 1. Number 3, we have W as the image because we go to the right 2 and down 6. Number 4, V is the image because we go to the right 4 and down 4. Number 5, Z is going to be its own image because we're not moving anywhere. We're not going to the right any, we're not going or left, and we're not going up or down any. Then number 6, we're going to the left 2 because it's a -2 for the x, and down -4. Now remember, these are not ordered pairs. This is vector notation for translations. Okay, the last thing that we're going to look at today are dilations. So a dilation is a type of transformation that causes an image to stretch or shrink in proportions to its original size. So you're going to have scale factors with dilations. The ratio by which an image stretches or shrinks is known as the scale factor. If the scale factor is greater than 1, then the image is enlarged. And think about if you multiply something like 2, and you multiply 2 times 3, this number 3 is greater than 1. 2 times 3 is going to give you a number of 6. Okay? We've multiplied by a number that's greater than 1. It gives us a larger number. If we multiply by a fraction, 2 times 1/2, what it does is it shrinks our number. 2 times 1/2 is going to make a smaller number. Same thing if you multiply our original image by a smaller scale factor, or a scale factor that's smaller than 1, it's going to shrink. If you multiply by a scale factor that's larger than 1, then it's going to enlarge your figure. If you multiply the dimensions of the original image by the scale factor, you're going to get the dimensions of your dilated image. So let's say that you have this figure is your pre-image. It's been multiplied. I can go ahead and tell because it's because your A prime, B prime, and C prime make a larger image, this figure has been enlarged. It's been multiplied by a factor that's greater than 1. So let's look at some examples of this. Okay, before we do that, though, remember you cannot divide to get the scale factor. You must change it to multiplying by a fraction. So for example, if each side in the original figure is 4, and the new figure reduces each side to 2, what is the scale factor? Well, think about, you can't say, well, I'm dividing each side by 2, because you have to figure out something that multiplies by 4 to get 2. So 4 times 1/2 is going to equal 2. So you have to, the scale factor has to be a fraction. We cannot say that the rule is to divide by 2. Instead, you're going to say that the scale factor is 1/2. You're multiplying each of these numbers by 1/2 to get our new image. So here's some steps. If you like steps, find the original points and name each of the original points. Step 2, to dilate the figure, you must multiply each of the numbers by the scale factors. So the x value and the y value have to be multiplied by the scale factor. Then you're going to plot the new points and draw the figure and make sure that you connect your figure. So here's an example. We have A, B, C. We notice that A prime, B prime, C prime is larger, so there's been an enlargement. Most of the time you're going to see the scale factor as K equals a number. K is going to be your constant that is multiplied by each of your ordered pairs to give you your new image. So we're going to follow these steps, which is first find the original points. So our original points are A is at 1, 1, B is at 2, -1, and C is at -2, 0. So then I'm going to take each of these points and I'm going to multiply them by my scale factor, which is 2. So 1 times 2 is 2. 1 times 2 is 2. So A prime is at 2, 2. B is at 2. 2 times 2 is 4. -1 times 2 is -2. And then C, again, we're multiplying the x and the y values. -2 times 2 is -4. 0 times 2 is 0. So then when you plot your new points, you see that it is an enlargement. And you should know that it's an enlargement because your scale factor is greater than 1. For this one, our K value is 1.5. And even though it's a fraction, 1.5 is a fraction, that number is greater than 1. So it's going to enlarge our figure. So I want you to take a moment to go ahead and try this one on your own. Okay, so here's my answer, and I hope that yours looks like mine. I multiplied each of the x and y values by 1.5, and I plotted my new ordered pairs, and my figure, I can tell, has been enlarged just as expected because this k value was greater than 1. So some important things that you need to know about dilations is that the angle measures remain the same. Parallelism, the parallel lines remain parallel. Collinearity, that means that the points stay on the same lines. The midpoints remain the same in each figure, and the orientation or the lettering order remains the same. Something that's not preserved is the distance. This means it's not isometric or not an isometry. The lengths of the segments are not the same in all cases except a scale factor of 1. So dilations are going to create similar figures. So those are some important things that you need to know. So just another way of saying this, a dilation makes an object bigger or smaller by a scale factor. The scale factor, if it's greater than 1, then the object is bigger. If the scale factor is between 0 and 1, which means if it's a fraction or a decimal number that's less than 1, then your scale factor is smaller. You're not going to have a scale factor that is negative because you can't have a negative length. So enjoy this song and feel free to dance along if you like.
Transformation style. Transformation style. Flipping upside down. Then it's a reflection. Spun it round. Right angle. That's rotation. That is rotation. Side effects. It's called the so a people can slide. If you go transformation style. Transformation style. Transformation style. Transformation style. Rotation. Transformation style. Very hard to dance, 50 upside down. Then it's a reflection, spun it round. 360 quickly, that's a rotation. Transformation style.